Welcome to video 4.3. Today we're going to talk about how to calculate the average atomic mass of an element and how it appears on the periodic table. So remember from the last video that the mass of an atom is basically its protons plus its neutrons. So the protons is the atomic number and the neutrons is the atomic mass number minus the atomic number. However, if you look on the periodic table, you get a decimal for most all of your atomic masses. That is because it's an average of the isotopes that actually exist. We measure atomic mass in AMUs, which is atomic mass units. That is the unit that we use. And it is defined as 1/12 of the mass of a carbon-12 atom. An AMU is almost equal to 1 proton plus 1 neutron. Remember, that's what's in the nucleus. They both are going to have a mass of about 1. And it is going to end up being what we use to measure things. Measure the mass of an atom. Electrons have a really small mass. So when it comes to talking about the mass of a specific atom, we don't even count an electron. So the atomic mass, so we've talked about the isotope number and the mass number of an individual atom. So each individual atom is going to have a specific atomic mass that's going to be based on how many neutrons are in that specific atom. However, the atomic mass of an element, so this is talking about all of the atoms of oxygen, it's going to be a weighted average of the isotopes. Or we can look at this, and sometimes chlorine is chlorine 35 right here. Sometimes it's chlorine 37. Both times you've got 17 protons, you've got 17 electrons, However, your neutrons differ in those two different isotopes. So that means you're going to end up with a weighted average for all of the chlorine that exists in the world. And so you have to take into account the percent abundance and the mass that correlates to that percentage. So this is going to be a weighted average. It's not hard, you just have to pay attention to how you're going to calculate this. So how I always calculate this is I always start with the mass number of A, and then I multiply that times the percent divided by 100. And then I would add that to my next mass number. And then I would multiply that times its percent abundance divided by 100. And etc., until you're done. And you're going to add all that up and figure out what is your average atomic mass. So, right here it says calculate the atomic mass of unknown element X. Then identify the element. So here's where we're going to start with our mass number. And then we're going to multiply that times our percent divided by 100. So right here for isotope X6, its actual mass number is 6.015. So that's going to be, 6.015. And it's giving me a percentage of 7.59. So I'm then going to divide that by 100. So when I do that, I'm going to get 6.015 times parentheses 7.59 divided by 100, close parentheses, and I'm going to get 0.4565385. Then I'm going to end up adding this to X7. So I'm going to do the same thing. Mass number times percent divided by 100. And so that's going to end up being 7.016 given to me in the table right here. And then the percentage is going to be 92.41 divided by 100. So, right there I'm going to do 7.016 times parentheses 92.41 divided by 100, close parentheses, and I'm going to get 6.4834856. You can round that to 2 decimal places if it makes you feel better. Then I'm going to add those together. And I'm going to end up getting 6.9400, so I'm going to round that to 6.94 AMUs. If there were 5 lines in that table that gave me the initial information, I would end up with 5 different numbers and add those together. So when I look at the periodic table, I'm looking for an element that has a mass on the periodic table of 6.94 AMUs. And so identifying the element, this is lithium. So if you notice, there's going to be a lot more lithium-7 than there is lithium-6 based on the percentages. That makes sense. So that is how you calculate the average atomic mass. One other thing to remember is that we can change the number of neutrons fairly easily and not the number of neutrons. We can change the number of, neutrons in the nucleus, and it doesn't change the identity of the element. If we change the number of electrons, that doesn't change the identity of the element. It changes the atom into an ion. We'll talk about that more in Chapter 7. However, if you change the number of protons, protons identify an atom. So if we change the number of protons, that's changing the nucleus, because protons are in the nucleus. That is called a nuclear reaction, and that would change one element into another element. So that's when we are changing protons. And we'll talk about this a lot more at the end of the school year when we get to nuclear chemistry. But in the late 1890s, scientists noticed that some substances spontaneously emit radiation. What that means is they're changing their number of protons. And they called this radioactivity. What the protons and the particles that they emitted were called radiation. And this is why when you hear something called a nuclear reaction, if you've heard of a nuclear physicist, or if you've driven by a nuclear power plant, or you've heard of a nuclear bomb, any reaction that involves the change in the nucleus, that's changing the number of protons, is called a nuclear reaction. So just be aware that we are not going to change the number of protons at all until the very end of this course. So thanks so much for your attention.